This is an AS Pure Maths question on cubic graphs. G of x is equal to 4x cubed minus 12x squared minus 15x plus 50. Part A, use the factor theorem to show that x plus 2 is a factor of g of x. So I'm just going to write this statement down that if x plus 2 is a factor of g of x, then it's going to follow that g of minus 2 is equal to 0. And we want to prove that this statement here is true. So that's what we're going to do. We're going to work out g of minus 2. So remember, whatever the number is, you reverse its sign to get what you're going to replace x with. So this will be 4 times by negative 2 cubed minus 12 times by negative 2 squared minus 15 times by negative 2 plus 50. Let's work out that and see what we get. So 4 times by negative 8, that's negative 2 cubed, will be minus 32. Then negative 2 squared is 4, so negative 12 times by 4 is negative 48. And then got negative 15 times by negative 2, that's plus 30, and then plus 50. Now negative 32 minus 48 is negative 80, plus 30 is going to be negative 50, plus 50 is 0. So we can say, therefore, by the factor theorem, x plus 2 is a factor of f of x, sorry, of g of x. Part B. Hence show that g of x can be written in the form g of x is equal to x plus 2 times by this polynomial here, ax plus b all squared. There's a couple of ways we can do this. I can equate coefficients, or I can do long division. I'm going to do long division. So I'm going to take our g of x and divide it by x plus 2. So I've got 4x cubed minus 12x. Remember, if you've got any missing powers of x, you need to write them in as 0. I haven't here, so I've just got that. First of all, how many times does x go into 4x cubed? It goes into it 4x squared times. Then we multiply. So when I multiply by that by x, I will get 4x cubed, and then times it by 2. So then I will get plus 8x squared. Then we subtract. So this is 0, and then I'll get minus 20x squared, and then bring down the minus 15x. How many times does x go into minus 20x squared? It goes into it minus 20x times. Then we multiply minus 20x squared minus 40x, and we subtract that. So obviously this is 0, and we got negative 15, and it become plus 40, which become 25x. Bring down the 50, x goes into 25, x 25 times. We times by 25, and we'll get 25x plus 50, and no remainder, which is what we'd expect. And then that gives us this. So it means that g of x can be written as x plus 2 times by 4x squared minus 20x plus 25. But we need to write it in this form where it's something squared. So that means that we can write this as 2x minus 5 all squared. And you can expand the brackets just to double check, or you can factorize it. It'll be 2x minus 5 times by 2x minus 5. So we always want to write it in the form that they give. So we found a equal to 2 and b equal to negative 5. So we've got it in the form that they want, and we've worked out the values of a and b. Figure 2 shows a sketch of part of the curve with equation y equals g of x, that's here. Part C, use your answer to part B, that's here, and the sketch to deduce the values of x for which part 1 or part I, g of x is less than or equal to 0. Now, where is the graph less than or equal to 0? Down here. So we want to find the value of x for which that happens. So we need to work out what this coordinate is here. And to find that coordinate, we look at our factorized form of g of x, which is here. Now, this will give us the roots. So this part will tell us that there's a root when the value of x is equal to -2. In other words, when this bracket is 0. And the other bracket is going to give us when we have another root, and that's going to be when 2x minus 5 is equal to 0. In other words, when x is equal to or 2x is equal to 5, x is equal to 5 over 2. And that's going to be at this point here. Now, I know it's at this point because whenever you've got something like this and it's squared, this will always be a bounce where the graph bounces rather than where it crosses the axis. So it bounces at x equals 5 over 2 and it crosses when x is -2. So the graph is below the x-axis. In other words, g of x is less than or equal to 0 for values of x less than or equal to -2. And the reason it's equal to -2 because we're including the point where g of x is equal to 0. So that's the first part of part C done. Second part of part C is asking us when g of 2x is equal to 0. So g of 2x is equal to 0. Now, it's got 2x, not just x. So this is a transformation of this graph. Now, whenever we get a transformation of the type like this, where it's something times by x and it's in the bracket, you could think of this two ways. It's squashing the graph by a factor of a in this direction, or you can think of it as stretching the graph by a factor of 1 over a, also in the horizontal direction. I prefer to think of it like this, a squash by a. So the graph is getting squashed by a factor of 2 in this direction. And if it's getting squashed by a factor of 2, these x coordinates are going to get squashed closer to the origin. And in fact, what's going to happen is these coordinates are going to get divided by 2 when it gets squashed. So -2 will become -1. So if I change this to y is equal to g of 2x here, so this will become -1. And the -5 over 2, if we halve that, or sorry, the 5 over 2, not -5 over 2, if we halve that, that will become 5 over 4. So these are the points at which g of 2x is equal to 0. So that is when x is equal to -1 and when x is equal to 5 over 4. So that will be the solutions to that equation.